So this video is the second half of the log properties. This is just going to cover the condensing. So make sure you're good with your rules. And the biggest place a lot of people mess up on these is the not simplifying it after you condense. I'm going to go at a pretty quick pace because this is a video and you can stop it and go back and rewatch each example as many times as you need. Okay, so when you condense, you only have one log. These are powers, so that's going to be the square root of x. That's multiplication, so times x plus 1. And that's it. That's all you have to do. If you want to put big parentheses around this, you can, but that's it. That's all you can do for that one. This becomes a power, and that minus sign condenses to division. So this is going to be ln of x plus 2 squared over x. This is going to condense to multiplication. That's going to be division. That's going to be multiplication. And that's going to be a power. And that's going to be a power. So one log, condense the ofs. So this is 4 times y to the third over y times w to the fourth. And again, this is a great example of a problem where people would walk away too quickly because you can reduce the y's. So this is log of 4y squared over w to the fourth. Number 4, this is a power for the whole problem because the whole problem is in brackets. So I'm going to do what's on the inside first, and then I'm just making a mental note. When I'm done, I need to cube root the whole of. So this is log base 2 of x times x minus 4. And then I need to cube root that. If you want to distribute, you can. But it does you no good. It doesn't simplify it any farther. So distribute, don't distribute, it doesn't matter. Okay, number 5. This too goes to everything that's in the brackets. So all of my ofs are together and they're going to be squared. So this is log base 10, which you do not have to write. This is going to be x plus 3 divided by x minus 2 squared. But then I need to square all of that. And we talked about this in class. You could, or if it was multiple choice, they could square the top and the bottom separately. And we also talked about the fact that when you have a power being raised to a power, that was 2 times 2 to get this 4, not 2 plus 2. And number 6, this is multiplication. That's a power, and that's a power, which is actually a root. So this is log of the square root of x times x minus 3 to the 5th. But the only thing that's raised to the 5th is that parentheses. If you wanted to put all this in parentheses, you can, but it's all multiplication, so you don't have to. Number 7, this is a power, and that's division. So ln of x minus 4th to the 4th over x squared. Nothing can cancel, nothing can reduce. This is a power on the whole thing, and that's going to go to multiplication. So log base 3 of x times x minus 2. And then I'm going to 5th root, not the log. Make sure you're just 5th rooting the of. If you want to distribute that x inside, you can. It does nothing, but you can. Doesn't hurt anything. Number 9, let's see, power, which is actually a root, division, multiplication. So log of x squared over y cubed times the square root of z. And we had a conversation about why that square root of z is not on the bottom. If I wanted that z on the bottom, I would have to have parentheses here with a minus out front, saying that you want to divide by both things. But that's not the case. So the square root of z goes up top or out to the side. Most of the time you're going to see it up top. Number 10, I'm going to cube root the whole thing. That's a power, that's a power. This is multiplication, and this is division. So ln of x squared over y to the fourth times z plus 2, all cube rooted. And I can't clean any of that up. Number 11, ln of a over. This is a power for the ofs on the bottom. This times this. So a plus 4 times a minus 4, and all of that is cubed. You could lobster this and write it that way. It doesn't matter. It doesn't matter at all. Okay, number 12. This is a power, which is a root, through the bracket. So I have log base 2. This is multiplication. That's a power. So x plus 3 times x minus 3 cubed, and just the x minus 3 is cubed. And then I'm going to square root all of that. And then I'm going to multiply it by x to the third. Now, I think this looks really bad because I think it looks like the x to the third could be under the root. So if you ever have a root and then a little single like this thing, I'm always going to put it in the front. We talked about doing this. That's fine. You can do that. All of that would be fine. Okay, number 13. This is going to be the square root of all of this cubed divided by the fifth root of all of that cubed. So here I go. ln of the square root of 3x to the fourth to the third over the fifth root of x to the fifth to the third. Now, let me show you another way you could write this. You could do ln of the square root of 3x to the fourth cubed under the root. It doesn't matter. It doesn't matter if you do the power first or if you do the root first. Whatever floats your boat. I'm going to cube it first. So that's going to be 27x to the, when you have a power to a power, you multiply. So that's a 12 over the fifth root of x to the 15th. All right, now I'm going to clean. 27 is 9 times 3. So ln of 3 with a 3 left. Okay, we talked about there being an index out here. The index is whatever root you're doing. So this is the square root. So my index is a 2. I'm going to divide it into my power. So 2 goes into 12 6 times. So 6 come out. And that goes in perfectly evenly. So there are none left over. 5 goes into 15 3 times. Perfectly. And there's none left over. Before I walk away, I have to reduce. They're both single. They're very eligible. And when you divide, you subtract your powers. When you divide, you subtract your powers. Okay, number 14. This is division. So that would be log of 20 over 2, which is log of 10. But remember, if there's no base, it defaults to base 10. And log base 10 of 10 is 1. Okay, number 15. Division, multiplication. So this is log base 2 of 6 over 3x. Well, that can reduce. Log base 2 of 2 over x. Reduce the 6 and the 3 and leave the x alone. You cannot do the log base 2 of 2 here. Like, you can't make that a 1 because it's over x. You can only do this trick when there's just a log base 2 of 2. Number number 16. Log. Okay, now this is 16 to the negative 1/2. So think about what that means. That is the square root of 16, so that's a 4. But it's negative, so it's really a 1/4. Okay, over. Now this is 8 to the 1/3. I've already dealt with the negative. The negative is the division. I already have that. So this is 8 to the 1/3, which is the cube root of 8, which is 2. Well, this is multiple layers. I'm going to put the 2 over 1. I'm going to same change flip or KFC. Y'all know I call it Bojangles. So change the division to multiplication and flip the second fraction. So that's going to be log of 1/8. Number 17, the of is a 4a, and I'm raising it to the negative 3rd power. Just make sure that you do the whole of. So this is 4a to the negative 3rd. So that's log of, well, it's negative, so it's going to move. And 4 cubed is 64, but don't forget to cube the a. And that power is now positive because remember, we moved it because the power was negative. So just have good algebra. Slow down and focus on your algebra. Okay, so this is the square root of this cubed. So let's figure out what that is. The square root of 4x to the 4th cubed. Okay, well, I'm going to square root this one first because this square roots very nicely. The square root of 4 is 2. And again, I'm going to use that index thing that we talked about earlier. So 2 into 4 goes 2 times evenly. So that's the square root part, and now I need to cube it. So that would be 8x to the, remember when you have a power to a power, you multiply. So that's this piece. Now let's do this piece. So this is the 4th root of x to the 8th cubed. And again, I'm going to do the root first because it goes nicely. 4 goes into 8 twice. And then I need to cube it, and a power to a power you multiply. Okay, so now let's take all that algebra and let's put it back into the pre-cal. So I have log of 8x to the 6th, and I think before I covered all this up, that was a minus sign, so divided by x to the 6th. Can't walk away yet because I can reduce those. So that would be log of 8. Don't get excited and try to write 8 as 2 to the 3rd and kick the power out front because that is expanding. And the directions here say condense. 19. Log of 2 over 1/3 cubed. Okay, so make sure you're good with that. Log of 2 over 1/27. And then Bojangles. So that's log of 54. Okay. This 2 is a power for all of this, so that's ln of 2 over x squared times x divided by 4. This is all one big happy of. Remember, they're all moving back home, so they're all in the same house. So now I'm going to clean. So that'd be ln of 4 over x squared times x over 4. 4's cancel. And I can reduce the x's and have 1x on the bottom. Okay, last 3. Log of 9 squared, that's 81, times x to the 5th times 1/3. Well, I can do 81 times 1/3. 3 goes into 81 27 times. So that's log of 27 x to the 5th. Do not leave your answer like this. You have to clean it up. Okay. This 1/2 is a power, so that's a square root of the whole thing. So log of 4 over x squared, that's this part, to the 1/2, which means square root it. Again, I just want to point out the square root goes on the of, it does not go on the log. And then I can square root of 4 and an x squared. So that's 2 over x. Okay, 23. Last one. Log base 3. This is going to be a to the 5th divided by, so a to the 5th over. This is going to be a to the 7th times 27 to the 1/3, which is the cubed root of 27, which is a 3. But I can clean this. A to the 5th and a to the 7th is going to give me a squared on the bottom. So there you go. Okay, and I know that was fast-ish, so take your time. Once you've gone through and written everything down that you needed to, go back and just watch it again where you're not worried about having to write it down, so you can just hear it again. And again, I think the biggest issue I have seen in the past is the reducing and the cleaning up after you condense. So just be careful on that. Do the homework super, super careful and really, really pay attention to the answers that are posted and make sure that you're getting your answer as simplified as mine. But also remember that there are some things you can do that you don't have to do. So make sure you're understanding that. Like on this one, you could leave it like that, or you could distribute. I don't care one way or the other. On this one, you can leave it like this, or you can lobster it out. It doesn't matter. It's all equivalent. It's all good. So just check super careful.